Hello everyone. Today I'm presenting my project on memory interleaving and bank conflicts and parallel memory systems. I have implemented a 3D simulation website so that complex internal operation of computer can be understood in a simple and visual way. To begin with, in modern computer systems, the CPU is extremely fast, but memory access is comparatively slower. Because of this mismatch, memory often becomes a bottleneck. So the main goal of the system is to improve memory optimization and its performance by allowing multiple operations to happen at the same time parallelly. Now, we will first look at the system, how it is connected. So there is one CPU first, and there is one memory interleaving, which is also called as memory controller. It controls where the data will go in which bank. This is queue buffer. This is multiple banks. We will pause this simulation first. Now, this memory controller, in whenever CPU needs data, it generates requests. The way these requests are generated is called access pattern, memory access pattern. Now there is many patterns. First is sequential, which accessed one after one, which is simple and efficient, and there is no fixed order in accessing. It is called random, and in strided there is stepwise system 0, then 4, then 8, then 12. And to handle multiple requests efficiently, memory is divided in many parts. Like if CPU is requesting something, then already bank 0 is processing, then memory controller will send the data to bank 1, which is free, that it can control the different requests parallelly. So the optimization and the performance of the memory and the speed of memory increases. So the overall system of the computer is fast and optimized. So now there are many type of interleaving strategies. There is no interleaving, means if we do this, then memory controller will stop working its job and just CPU sends data to a single bank, and when it is processing, and if CPU is processing another request, then bank will wait and send the data to queue buffer. Here there is queue buffer. So bank 0 will send other requests to queue buffer and it will wait there. Now, whenever the bank is free and processed its first data, then queue buffer will be empty, will get empty, and the request then will be processed one by one. If we select low order, then to select which bank, lower bits of the address is calculated. On that base, bank is selected, and that data is going to that bank. So by this, the the conflict bank conflict will it will be decreased, and if then there is a high order, it if we do high order, then it is based on the higher order bits of the address. So in real world, low order bits is more useful. So we will do the simulation of low order, and this is conflict resolution strategy. Now, if there happens one conflict, then that is many strategies stall. If conflict is happen in bank 0, then it will process one data, and the system then if then memory controller stops sending data. So the conflict doesn't happen, and in queue buffering, the request will go into the queue buffer, and in reorder request, system changes the order of request to process. Those can be handled immediately. So in retry later, the request is sent back to the memory controller, and it will be attempted again after some time when the bank is free. Now here we will use queue buffering, and here we will do no interleaving. So we can firstly see if there is no memory controller, then what happens and how much time it takes to bank 0, only one bank, to process all of the data. We will here everything low for the the process will be fast. Now CPU starts sending data to memory controller, and there is no interleaving selected, so the memory controller won't do its work. Memory interleaving sends all of his data to bank 0. And look here, this plot total is increasing. Q buffer is filling one by one. The more the memory controller sends the data, Q buffer will get filled, and bank is processing the current operation which is given by read then write. One by one it will process the operations, and Q buffer will be getting empty. Now we will close this, it reset, and we will try another no order which is currently using in most of the computer, and this is a reorder request. Here we will do random, so we get to know multiple things. How can it happen? The system is starting. Here there is live explanation what is there. The system is starting. Parts will appear one by one. Parts now has appeared, and CPU is ready to create data requests. So memory control is also ready, and it sends each request to the correct bank. Now we have selected it as a random, so it will give any to it here to bank 3, and there is conflict created. So here this is one by one system is sending the data to queue buffer, and it will increases and decreases one by one as the processes happens. By this all of the bank are working. So by this the process is getting faster. We have seen in first situation the queue buffer is already full at the starting. Now here it is almost half. So by this the memory the speed of the memory is increased and performance is increased. Now there is another best situation which is we will do a restart, and no order is the best and which is we currently using, but parallel issue we will do, and because start. So CPU is ready, system is starting part will appear. Now here CPU is ready, it will create data request, and memory control is also ready, and it sends each request to the correct line. Now it is sending, there is conflict one and it is already resolved. Another conflict is created and resolved. Queue buffer is empty. Another creates. Now here we can see the performance with utilization of the code, and here we can see the rate, conflict rate, utilization, latency, throughput, how many tasks is completed, read, read operation, write operation, how many active banks are there. If the process is stopped, then it is called styled, and it shows here. Now two requests try to use the same memory, so it creates conflict. Now the memory bank is processing request data internally, which to read or write profession, whatever the CPU requests the data. Now here the queue buffer is already empty and the data compression is completed. Now we have seen in first there is queue buffer which is very full and not getting empty. Then in second scenario we have seen that queue buffer is almost half and just increase and stay remains same. But in last we have seen that operation is already finished at this time and queue buffer is also empty and CPU stop requesting. So by in this we can get the best optimal answer, and by doing this parallel operations we can achieve faster performances to. Now this project demonstrates how memory system works internally, how conflict occur, and how different strategies help in improving performance. By visualizing this process, it becomes much easier to understand the behavior of modern computer systems. Thank you.